Hey y'all, today's lesson is volume of spheres. Again, we're going to use, rolling my back. We're going to use your textbook. So I want you to go find or tear out page 495, 496, 497, and 498. And we are going to use those pages for your notes. Again, this is volume of spheres. There's a definition of a sphere. It's a set of all points that are given distance from like a radius from the point in the middle. So it's a three-dimensional circle, and it's basically a bunch of circles all wrapped around with one centralized point. This page is, a graphic organizer. Usually we name spheres by the point in the middle. Circles are usually named with O. Spheres, I don't know if that would be O, but you'd name it by the point in the middle. If I wanted to turn on the answers, you could see, but I'm not going to do that. Next page, the very top gives you the formula for the volume of a sphere. Now, in the other formulas for cylinders and cones, we had base area, capital B, base area. But in spheres, we don't have a base. We don't have anything for the sphere to sit on because it's round on all the sides. So the formula is different, yet similar. So it starts with 4/3 pi r cubed. So there's the difference, pi r cubed, not pi r squared, but pi r cubed. And I'm sure if you really wanted to know, you can ask me and I could show you where the formula comes from, or you could look on Google and find on YouTube, where does the volume of a sphere come from, if that is something that you're interested in and you really want to know why it is what it is. But for the sake of this video and the direct instruction, we're just going to go through. Here is the formula. Write this down. Write it. Well, I guess you have it in your notes, so circle it. Just like with all the other notes, they have an example done for you. So we are going to go to the got it problems, and I will work through these together with you. A and B. Round to nearest 10th. Okay. So we are rounding to the nearest 10th for these two spheres. I cut off some words right there. So the volume is 4/3 pi r cubed. And again, I'm going to write the formula every single time. I expect you to write the formula every single time, and it's just going to help you get it in your memory. I'm going to use 3.14. So 4/3 times 3.14. Oh no, I'm getting a call. I'm going to have to call him back. And then r cubed, this is the diameter. Is that 22? I think I just learned 22. So the radius is half of that, which is 11. So 11 cubed. Now, I don't know 11 cubed off the top of my head. I know 11 squared, but not 11 cubed. So I'm going to type in 4/3, and I'm going to show you how I'm typing in 4/3. So 4 divided by 3 in parentheses. 4/3 times 3.14 times 11 cubed. And there is my, 11, can't see it, 11 cubed. And when I finish, and I think it said round to nearest 10th. Let me just check the directions. Round to nearest 10th. Okay. So where am I? 5,572.45. Oops. 0.45. So 0.5 centimeters cubed. Again, volume is cubic centimeters. And that's how many cubic centimeters could fit in that sphere. Now on B, I want you to start with the formula again, 4/3 pi r cubed. I hope you have your calculator, because if you're sitting there watching me type in, that's not helping you at all. 4/3, I'm going to just choose to use the pi key this time. I'm going to show you how to use the pi key. And then the radius is 5, so 5 cubed. Oh wait, I'm just going to write my answer now. So I'm going to show you 4/3. Now the pi key is like the second function over here somewhere. Oh no, wrong one. It's the second function over here. So I'm going to press second pi, and then I'm just going to show you what my screen looks like. 4/3 pi times 5 to the 3rd power. I can't ever get it. And when I push my answer, round to nearest 10th, so I get 523 mine says 5.9, so that means it would be 0.6 millimeters cubed. And that is the volume of that sphere. Now, again, it's just using that formula and getting used to plugging in those numbers to find the volume of a sphere. Let's find the next example. No, I don't want to say that. And here is a real world example where it's talking about a spherical stone. So you can read that one. Next page at the top, we have dish contains a spherical scoop of ice cream at the radius. What's the volume? Okay, that one you can do on your own. I'm going to go to the multi-step. Here, there's this extra step. A pump can inflate the ball at a rate of 325 cubic inches per minute. And this problem gives you step by step, but do you see me? Wait, no. I'm going to, right here, it adds this extra step. First, you find the volume. Check. We know how to find the volume. And then you have to add this extra step of writing proportion. So that's what I'm going to be showing you in this next one. So this next got it about the snowball. Gotta love technology. Just moved me everywhere. Okay. A snowball has a diameter of 6 centimeters. So right off the bat, I know this is diameter. So a radius of 3 centimeters. How long would it take the snowball to melt if it melts at a rate of 1 cubic centimeters per minute? So that is our rate, and that's what we're going to use for our proportion, round to nearest tenth. So first we need to find the volume. 4/3 pi r cubed. 4/3 pi. Actually, I'm just going to use 3.14. So 4/3 times 3.14 times the radius is 3 cubed, which that's 27. So let me find the volume. Type this in yourself. Don't be lazy and watch me type in numbers. That's wasting time. 3.14 times 3 to the third. So the volume of the snowball is 113.04 centimeters cubed. That's the volume. So now I need to set up my proportion. And I'm going to go ahead and use this rate. 1.8 cubic centimeters is this. Cubic centimeters or centimeters cubed. It's the same thing. Per 1 minute. Now, this is also cubic centimeters. So I need to put it up top with the cubic centimeters. And then here is my variable. The question says, how long? That's what it's asking us for. Can you read that? Asking how long. That's why the time is my x. So I'm going to cross multiply. 1.8x equals 1 times 113.04. I'm going to divide by 1.8. And I don't actually have 113.04 divided by 1.8. And I got 62.8 minutes because this is, oh, sorry for that, crazy S, minutes. How long it would take for that snowball to melt. And it would take over an hour for that snowball to melt because it melts at a really slow rate, 1.8 cubic centimeters per minute. So it would take over an hour for that snowball to melt. So this was the multi-step problem. First, you find the volume, and then you use that rate, and you set up a proportion. Okay, another example to do. Okay, volume of a hemisphere. A circle can be cut in half, and it's called a hemisphere. Like northern hemisphere, southern hemisphere, eastern hemisphere, western hemisphere. And I'm not going to ask you to like memorize a whole nother formula. You're just going to find the volume, and then you're going to take half of it. Now, whether you take half or divide by 2, that's going to be the same thing. So I'm going to show you these last 2 examples at the very top of page 498. So these last 2 examples, E and F, and then we will be done. I don't even know how long this video is because I don't have a timer when I'm videoing. E. So we have a hemisphere. Volume is 4/3 pi r cubed. So on this one, I'm going to show you can multiply a half in the front and 3.14. And then the radius is half. So this is the diameter. So the radius is 1. Oh, well, isn't that nice? So that's a lot to type in, but I'm going to show you. So I always use parentheses. 1/2 times 4/3 times 3.14 times 1 to the 3rd power. So the volume for that hemisphere is 2.09333. And I'm sure the directions said rounds in yours 10th. 2.09 would be 2.1 centimeters cubed. Now for F, I'm going to show you another way. Neither one is better than the other. Neither one is right and wrong. They're both correct. So in the second one, 4/3 pi r cubed, and then I'm going to divide by 2. So 4/3 times pi times the radius. This is the radius, so 9 cubed, and then I'm going to divide that by 2. So I'm going to show you 4/3 times pi times 9 cubed. I hope that you are doing this yourself and not just watching me, because that would be boring and not helpful. And then I'm just going to divide by 2 because I only want half of it, and I get 1,000. I'm trying to look at my computer. I mean, my calculator, but there's like a glare. 1,000. 500. No. 1,526. 0.04, so you could just say 0.0 meters cubed. If you use the pi key, you might have something a tiny bit different, but 1,526 is that hemisphere. So again, you can put the 1/2 in front of it like I did with example E. I should be highlighting or something for you. Let me figure out. I'm like pointing to my computer, but you can't see that. Uh-oh, I just got a notification. I need to move. I've been sitting for too long. So where is my... I think that's a highlighter. So in this example, I put the 1/2 at the beginning, and in this example, I divided it by 2 at the end. Both mean the same thing, and they accomplish the same thing. So when you have a hemisphere, I don't want you to have to think of a new formula. You're either going to multiply by 1/2 or divide it by 2. All right, we'll practice more spheres soon. All right.